The avionics bay of the high power rocket is where we're going to house the electronics that'll control the deployment of the drogue and the main parachute. As you can see, we've got bulk plates, one for the top and one for the bottom of the avionics bay tube. Those will go on each end here, and they're held together with the 1/4 20 all-thread rods. I've set up the electronics that I'm going to use. I have a MissileWorks RRC3 altimeter, an RRC2 Plus altimeter, 2 screw switches, and then the battery holders. The tube is about 9 inches long, and so just to give some adjustability and prevent wires from pinching on each side, I've made the sled 7 inches long and just narrow enough to fit inside the tube. So what I'm going to do is cut out the sled here, then cut out 2 smaller pieces with the holes that'll actually mount on the all-thread rods, and that'll be held in place with a 1/4 20 nut on each side. That'll keep the sled nice and secure. Then I can start wiring up the altimeters from the battery to the switch to the altimeter itself, and then start running wires for the electric matches. Those will come up through the bulk plates and into the terminals here. And then we can start testing the electronics for deployment. Here's a better look at how the electronics bay is going to be set up here. I've got the drogue side bulk plate in place, and that's mounted permanently or semi-permanently using 1/4 20 nuts. I've just got some 1/4 20 nuts in place right now to hold the sled in position. And this will be the bulk plate for the main parachute. That's going to be held on with a pair of wing nuts. What I've done here is I've marked the distance from the bottom of the avionics bay coupler tube up to where the vent holes are. And the vent holes are where I'm going to access the screw switches. So I've marked the location where the screw switches are going to go. Now I'm not going to glue them into place until I actually have the avionics bay in place, because it's a very tight tolerance to get the screwdriver in through the hole and to hit the screw perfectly to turn on the avionics. So that'll come a little bit later, but right now I'm going to set up the avionics bay with the altimeters in position. Probably do 1 battery pack on this side, 1 battery pack on the other side. It's just not enough room to put 2 battery packs side by side with the curvature of the tube. But this is what the avionics sled looks like. It's just a 1/4 inch plywood, and these are the flanges that are holding it on to the rods, and I pin them in place with some small screws just to make sure they're nice and tight. So I finished mounting my electronics onto the sled in the avionics bay, and you can kind of see how this all goes together here. I've got a battery holder on the front, a battery holder on the back, and I've got spots for 2 zip ties to go around and secure the batteries in place. Then I have the screw switches up here in the middle, and they're angled and arranged so that I can fit a screwdriver through the vent holes here on the avionics bay, and that's how I'm going to activate the avionics, how I'm going to turn them on. Now the screw switches are simply just screw heads that you screw down into the metal here, and that completes the connection from the battery to the altimeter. And at the top I have the altimeters here. I've got the RRC3 on the left, RRC2 Plus on the right. They're held in place with 440 screws and nylon washers to stand them off of the sled here, because the actual pressure sensors are on the bottom side of the altimeters here. So I'll talk a little bit more about the function of the altimeters later, but I just wanted to give you an idea of what the sled looks like here. So next up I'm going to wire up the batteries to the switches, then the switches to the altimeters, and I'll also run wires from the altimeters to the terminals here for the electronic matches. And I'll do this on both sides here for the bottom bulkhead and the top bulkhead, and then we'll be ready to test the altimeters and test the charges for the rocket. So I've installed all the wiring for the 2 altimeters and the screw switches here, and I've loaded up the 9-volt batteries. One will power each board. I've got a 9-volt on the back side of the avionics sled here. I do have some lithium polymer batteries that I'm going to add later, but just because I'm a little crunched for time for the first launch here, I know that 9-volt batteries work well with the RRC2 and the RRC3, and so I'm going to use 9-volt batteries for now and hopefully get to the lithium polymer later. Because the RRC3 allows me a little bit more variation in the programming, I'm going to use the RRC2 Plus as the primary altimeter in this rocket. So what I've done is I've set it up for a primary roll, which means for the drogue charge there's going to be 0 delay, so the drogue charge will fire off of this altimeter right at the apogee of the rocket. And then I've set the main deployment altitude for 800 feet. I really like the RSC2 Plus because it's so simple to program. It really is just plug and go, and all you have to do to program it is just set the dip switches here. The reason that I'm using the RSC3 as a backup instead of the primary altimeter is because I can fine-tune how much of a delay I want after apogee to fire the drogue charge. With the RSC2, you can either use 0 seconds or 1 second, and I found that 1 second isn't quite enough to give me a comfortable margin so that both altimeters aren't firing at the same time. So in the case of the RSC3, I'm going to set the delay for 2 seconds after apogee. This will give enough spacing between the primary charge and the secondary charge to make sure that I'm not blowing both charges at the same time and maybe overpressurizing the rocket. Now the RSC2 is very easy to program with just the dip switches here. There are several different ways to program the RSC3. The method that I like to use is just the LCD programmer from MissileWorks. So I've got it plugged into the RSC3, and I'm just going to power on the altimeter using the screw switch. So with the programmer powered up, we'll go into the Set, Base menu. The Arb Altitude is the altitude at which the altimeter will recognize that the rocket is in the air. Now 30 here means actually 300 feet, and that's fine. There shouldn't be 300 feet difference in pressure between the time I turn on the altimeter and the time the rocket actually launches. Main altitude, this is at 500 feet, and so I'm going to increase it to 600 feet. So I'll have the main charge go off on the RSC2 at 800 feet, then 200 feet later during the descent, the backup charge will fire from the RSC3. For deploy mode, mode number 1 is for using the RSC3 as the primary altimeter. We're using it as a backup, so we're going to set it to number 2. There it is. And that'll give it some delay after the drogue charge. After setting the deploy mode to the backup, we can go through the audio setup, unit setup, and low voltage lockout. And the piezo tone, here's the drogue delay. So this is where I'm going to set it for 2 seconds. And then we're back to the Arb Altitude. So we're just going to back all the way out to the home screen, and that'll save all the settings to the flash. And so now the RSC3 is all programmed and ready for flight. Recovery gear for a high power rocket is pretty similar to a low power rocket with a few key differences. Other than the obvious being that we have 2 sets of recovery gear for a traditional dual deploy. We've got 2 shot cords, 2 parachutes. We also have 2 Nomex blankets here to protect the parachute. Now with an Estes kit, you're using disposable recovery wadding that looks a lot like tissue paper. With a high power rocket, we're using something a little bit more substantial, and this is also reusable. So it's like having recovery wadding that you don't have to throw out and get new replacements for. So that's kind of nice. To attach the recovery gear to the rocket, I have these tubular nylon harnesses here, and I'm going to loop one end around the loops on the rocket, which would be one loop on the nose cone with the U-bolt, and then one loop on the booster section with the Kevlar that sticks out. On the other end that attaches to the avionics bay, I'm going to use the quick links here. This will allow me to easily disconnect the recovery harnesses from the avionics bay so I can prep charges and set up the avionics bay really easily, and then attach everything together to complete the rocket. Now to attach the main parachute to the main harness on the top end, I'm simply going to tie a knot in the top end here and attach the parachute to that. For the drogue parachute, which is a little bit smaller here, I'm going to use this smaller quick link to attach to a loop that's sewn halfway up the harness there. This quick link will also give me an attachment point for my GPS tracker, so that's why I'm going to use that on the drogue line. So with that said, it's time to get everything hooked up and start completing the rocket. Here's the drogue recovery harness. So I'm just simply going to loop it through the Kevlar here on the booster tube, like so, and feed it through so that the loop where I attach the drogue parachute to is on the side that's closer to the avionics bay. Now these harnesses are from a company called One Bad Hawk Recovery. They make all sorts of different harnesses, Kevlar, tubular nylon, and really big fan of their work. That's what I'm running in all my high power rockets. And I should mention that I'm not sponsored by any of the companies that I've been mentioning during this build. I just happen to like their products. I also just want to pass on what's been working pretty well for me. I happen to like these tubular nylon harnesses because they have just a little more stretch than a Kevlar does, which takes some of the shock load off of the recovery harnesses, off of the U-bolts and the bulkheads. There we go, that's nice and secure. Now I'll attach the quick link. Here's the loop that's been sewn in. As you can see, it's very close to the Avionics base side. There we go. And this drogue is a 20-inch diameter recon recovery parachute. The recon recovery chutes are hemispherical, and so they have a little bit higher coefficient of drag than a regular flat parachute. So you can get away with running a slightly smaller recon parachute than you would a standard flat parachute. So if I were to run a standard parachute, I'd run a 24-inch for the drogue on this rocket, but since it's a recon, I'm running a 20-inch. So I'll be sure to come back and tighten down the quick link with pliers here before actually flying the rocket. Also, I'll be attaching my GPS tracker to it, so that's why I'm not too worried about making it too tight right now. Now I want to set the Nomex blanket here between the black powder charge and the parachute. So I'm actually putting the parachute protector here on the forward side of the recovery harness. So this will go here. And now I'll add my main quick link. There we go, and I'll leave that off of the Avionics bay right now because I want to prep black powder charges for the charge testing. So that's it for the booster section recovery gear. Following the same procedure for the drogue recovery harness, I've set up the main recovery harness here. First looping it through the U-bolt and the nose cone, then attaching the parachute and the Nomex blanket, and finally the quick link. Now I'm going to thread all of the gear through the payload tube and then attach the nose cone to the payload tube here. And I want to make sure that the Nomex blanket is below the main parachute, and that'll protect it from the black powder charge. And I'm going to set this up for real because I'm going to be testing the black powder charges next. To calculate how much black powder I want to use for each charge, I go onto the internet and found a black powder charge calculator. All you have to do is just search it up. I think there's a link on the Utah Rocketry website, urock.org. Anyway, coming up with the dimensions that I have for the rockets: 4 inches in diameter, about 21 inches of area in the upper section, and 26 inches of total length in the booster section. I came up with 1.4 grams of black powder for the main, 1.7 grams for the drogue. This will give me a 10 psi on the bulkheads, which is 125 pounds total, easily enough to break 2 of the shear pins. I'm going to start the charge testing by loading up the charge well for the primary charge on the drogue. So I've got the Avionics bay upside down right now. This is the drogue side, this is the bottom. So I've already calculated out that I'm going to use 1.7 grams of black powder for the drogue section here. So I'm going to measure that amount out on my scale. There's 1.7 right there. We're pretty close to it. So that's ready to go. And I'm going to pour it into the charge cap. As you can see, I've labeled the charge cap P for primary. And once I determine the best amount of black powder for each charge, I'll actually write down the amount so I don't have to remember for each different rocket that I have. So the idea here is to get the ideal amount of charge figured out, and then for the backup, just add a little bit, about 0.2 or 0.3 grams of black powder. The idea being that if the primary charge doesn't do its job, that the backup charge kind of follows the blow it out or blow it up philosophy, and it's a last-ditch effort to get the rocket separated. So right now I'm taking my electric match screwing it into the terminal so that it's nice and tight. I'm going to insert the electric match into the black powder, like so, and then just push the wires down. Now what I'm going to do is take a little bit of Estes recovery wadding here and just crumple it up and pack that down into the charge well to keep the black powder nice and tight. This will give me the best ejection. And what I'm using here for black powder is 4F black powder, which are the smallest grains that you can get. Little piece of tape on the top to hold that all in place. And I'm also going to put a piece of tape over the terminal screws here, and this just protects the exposed screws from the corrosive black powder. Just helps the terminals last a little bit longer. And with that in place, just going to take one more piece of tape, wrap it around the charge well here, just to help keep it sealed and make sure black powder isn't spilling out during flight. So there we go, there's the primary drogue charge. It's all ready to go. All I have to do is put the rocket together and turn on the altimeter and test it. And I'll get into testing in a little bit here. But what I'm going to do for testing purposes is I'm going to use the primary altimeter to test the drogue charge, and then I'm going to use the backup altimeter to test the main charge. That way I'll have both altimeters tested for flight. So I'm going to flip this Avionics bay over, do the same process here, and put 1.4 grams of black powder into the backup well for the main. So because this is a full dress rehearsal, I have the packed drogue parachute in place in the booster section, and I've started threading in the shear pin. So all I need to do right now is just attach the harness to the av bay, and then place the av bay in position. Get that lined up just right, and then I'll screw in the shear pin here, and the booster section will be ready for testing. And I'm going to have the whole rocket together for testing here, but this is the first section that I'm going to put together. Okay, I've got the shear pin in place, and it's important not to over tighten the shear pin because you don't want to stretch out the nylon and change its shear properties. So that's in position. I have the booster section, or I'm sorry, I have the upper section all ready to go. The main parachute is inside. So all I need to do is attach the quick link to the U-bolt on the av bay. Then I'm going to slide the whole upper section in place and complete the assembly by screwing in the 3 bolts that hold the payload tube to the av bay. There we go, all of the bolts are in place and the rocket's completely assembled. Last thing I need to do before actually doing the test is I need to simulate a motor inside of the motor mount here by stuffing an old rag or something, just to prevent ejection gases from exiting the motor tube, because that would kind of defeat the purpose of the test here. So I'm going to go find a rag, and we'll make sure that the motor tube is blocked off, and we'll be able to take this rocket outside and test it. So here's my setup to test the drogue charge on the Drago. As you can see, I've closed off the motor area so the ejection charge won't go through the back there. I have a shop vac, and what I've done is I've run the shop vac to one of the static ports. And I've taped over the static port on the back side. The only static port that's left now is a static port for the primary altimeter, and that's the one that I'm going to put in the screw to turn on the altimeter. So it's all set to go. And as you can see, I've left the grass long on the yard. That'll help protect the nose cone and the payload tube as much as possible on landing here. So I want to get this charge testing done so I can get the lawn mowed. So what I'm going to do is I'm going to screw in the screw switch. I'm going to let it go through its power up cycle. What it's beeping out now is the last altitude of the last flight. Now this thing hasn't flown yet, so that's the the testing that MissileWorks did on the altimeter. Now it's going to beep out the voltage of the battery. It should be somewhere above 9. This is a fresh 9 volt. There's 9. Okay, 9.5. Now I'm listening for either 1 or 2 beeps. I think it's just 1 for the drogue match. Yep, there's the 1 beep. So 1 beep with the MissileWorks means that only the drogue match is connected. 2 beeps means only the main is connected, so that's what we should hear on the next test. And 3 beeps would mean that both drogue and the main match are connected. So now that the altimeter is ready to go, I'm going to tape off this static port here. And just be careful there not to get over the tape for the hose, because the hose is connected up to the section that's going to be shot off. And so I've done the best that I can to make a seal here, and also not tape over the section that's going to split. Now this tape is most likely going to pull away when the rocket separates, so I try not to put it on too tight, but I want to make as good of a seal as I can. So we're all set, so I'm going to stand back a little ways. I'm going to turn on the shop vac. And once the pressure inside the av bay equalizes as much as the shot vac can pull, the drogue should sense, the altimeter should sense that the rocket's reached its apogee and fire the drogue charge. So I'm just going to leave it on until the thing fires, and I'm going to step back after I turn on the shop vac. Here we go. Okay, as you can see, the rocket did separate. However, it did blow the rag out the back. So it wasn't as pure of a test as I was hoping for. Now it did separate the shear pin, which I'm happy to see, but the upper section didn't get very far. So I'm not sure if that would be good enough for an actual flight to pull the drogue parachute out. So I'd like to redo that test. However, I think the amount of black powder that I use is pretty good. I just want to see it go without blowing out the rag out the back and see how far the section gets. So the altimeter right now, it's beeping up the altitude that it thought it got, which was 2,600 something feet, which is great. That was a good vacuum that I got on the rocket. So I'll reset for another drogue test. However, before I do that, I'm going to test the main parachute since it's all together right now. Okay, so time for the main parachute test. I'm testing the other altimeter, so I've hooked up the shop vac to the other static port so I can easily reach the backup altimeter on the left side here. So this test isn't quite as critical for the vacuum there being able to break away, since only the nose cone is going to pop off here. So we're going to turn on the backup altimeter, let it initialize, and I'll plug up the hole, and we'll do the test just like we did before. There's 2 beeps. That means that the main electric match is connected. So I'm just going to plug up that statical. Now this time the charge won't fire until the rocket altimeter thinks that the rocket's descending. So what I'm going to do is turn on the vacuum and let it run just for a few seconds here, then I'll turn it back off. And as the pressure starts to increase in the altimeter bay, the altimeter will fire the main. So here we go. Okay, so as you can see, both the shear pins did shear. The parachute did get out of the rocket, but only just barely. So I think I'm going to increase the amount of black powder that I use on the main charge. The nose cone blew cleanly away, which is great, because you don't want the main parachute to get caught up inside the nose cone. However, I think for the main charge and for the drogue charge, I'm just going to increase black powder by a small amount, and then we'll try the test again. All right, so I've got the rocket reset here. We're going to use the backup altimeter this time to test the drogue charge. So we'll get that turned on, and we'll give it another shot. A little more black powder. I've got the motor tube sealed up a little bit better. There we go. Okay, so that's sealed up. Let's give the drogue another shot. Okay, take 2 on the main charge, just a little bit extra black powder. And this time we're testing the primary altimeter for the main charge. We're getting good beeps from the altimeter. Time to test the main again.
Pad is armed. Going in 5, 4, 3, 2, 1.